So I have the privilege to introduce to you a new service that NTS is in the process of launching. This is our first public showing of this service. We call it our SmartTrac Farm Plan, and at the face value, the purpose of it is to take a look at the issues that you're having on your farm with regard to tires and tracks, and figure out what's the best way to overcome those issues, and ultimately, what's the best way to make changes to increase your profitability. So the first question I want to ask you is, if you can see this list, and I'll read through it, think about which of these common problems you may be facing on your farm. So we have soil compaction, sinking, rutting, not enough traction, power hop, road boat, slow travel speeds, poor handling or steering, rough riding equipment, premature wear, or tire or track failure. Just think for a moment. I was actually presenting this to a farmer yesterday morning, and after looking at the list for about a minute, he stops and looks at me and he says, "Where's the list for all of the above?" Most farmers are dealing with most of these issues, and so the SmartTrac Farm Plan is designed to not necessarily alleviate these entirely. Certain ones we can. Power hop, for example, is usually one that we can get rid of entirely, regardless of what you have. But on the other ones, we're looking at, well, what incremental improvements can we make that's going to make a difference? I don't know if you guys in the corner can see this photo, but this is one that's actually taken with a drone of our farm. And the right-hand side of the photo looks all right, but here, or the left-hand side, but on the right-hand side, you'll see some tracks very clearly going through the field. And I'll put up a list here. These are all the different pieces of equipment that went across this field in a year. So there was a combine, 850 bushel grain cart, a quad track tractor and ripper, self-propelled sprayer, a quad track tractor and field cultivator, and then a mechanical front wheel drive tractor and planter. What I want you to do is, I'm going to name these off and raise your hand if you think it was caused by that piece of equipment. So at the top, who thinks this was caused by a combine? Okay, one. Grain cart. A few more. The quad track and ripper. We have one. Self-propelled sprayer. That's probably winning right now. Quad track and field cultivator. You're just saying everything.
Well, everything but the ripper.
And the mechanical front wheel drive tractor and planter. Couple there. Okay, so only one piece caused those tracks, and it was the quad track and the field cultivator. and I like this because it proves a couple points. I don't know if I can consider you being right. You had your hand raised for all of them except for one. But the first point is, when we're thinking about compaction on our farm, the last thing we want to do is rule out something that truly could be your biggest compaction issue, and start spending a lot of money on something that you think is your compaction problem, but at the end of the day, maybe it is a problem, but it's not your biggest problem. And the second point is, a lot of farmers have the misnomer that if you have tracks, you don't have compaction. That couldn't be further from the truth. There are times and places where tracks are the best option, maybe not the perfect option, but they're a better option. But just because of how they're designed with the idlers and the mid-rollers, you typically have very high pressure points under your track mid-rollers. And so you're not having an even footprint, which means your compaction is higher than what you would think it would be. I'm going to run through a couple studies that have been done over the years. This was a 15-year study that was done trying to measure what is the yield loss from soil compaction. So what they did is, in the first year, they set tires to 40 psi, and they compacted a field and measured what the yield loss was against a control group. And what they saw year one, compaction yield loss was 15%. They tilled the field, and then they did not compact it anymore in subsequent years. And they saw the yield loss reduce over time. So by the time you got to about year 5, the yield loss compared to what hadn't been compacted was about 5%. By year 10, they saw the yield loss was down to 3%. And then from that point on, that 3% yield loss stayed. And so what they were seeing was essentially your topsoil compaction over time would go away. But your subsoil compaction, once that's there, that's basically permanent. You could probably go many decades and still never regain the original state of your soil. So this is a big issue as equipment's getting bigger and bigger all the time. We don't want to be having such high pressure and such high pounds per square inch that you're starting to drive compaction into the subsoil. This is a map of a 48-row swath on our farm. And what you can see here with each color line is a place where a tire had driven during one growing season. And the darker ones show multiple passes in a track. And I think this is roughly about 60 to 70% coverage. But typically what a farmer has is 60 to 80% of every square foot of their field is being hit by a piece of rubber. So when you think about how widespread your compaction is, it's affecting a lot of acres. And we know why compaction hurts yield, and it ultimately comes down to root development isn't what it could be, and that means it can't get to the nutrients. Sometimes it affects how accessible moisture is to your crops. And if you take a pentrometer and stick it in the soil, typically root penetration is going to be 100% up until about 100 psi. By the time you get to 300 psi, root development is basically stopping. It can't penetrate that. At 200 psi, you're at about 50% of your root growth potential. And oftentimes what we're seeing with farm equipment is a resistance between 200 and 250 psi. Obviously it varies based on the equipment and application, but you're sitting down here typically. What we want to do is move your root development up the line, get closer to, say, a 150 or even a 130 pound per square inch root penetration. And this was a study that was also done that caught my eye. This is showing earthworm counts in soil and how that's affected by compaction. There's some farmers who value earthworms so much that they'll actually go out and they'll count how many earthworms they can pull up in their soil because they understand that they're massively beneficial as far as allowing water to infiltrate into your soil, recycling your nutrients and whatnot. But what they did here is they tested an area that had no compaction, and the earthworm count, they extrapolated to 166,000 earthworms. After 1 year of compaction, that number was 110,000. They then did deep tillage to try and get rid of that compaction, and the tillage itself actually reduced it even more to 100,000. And then they did it over many years, and with a 6-ton axle load after 5 years, the earthworm count was down to 20,000. And with a 10-ton, so a heavier axle load, after 5 years, it was down to 8,000. So these are other issues that you may not think about that compaction is creating on your farm. Depending on your farm, depending on what corn price you want to use or what your typical yield is, what studies show are a 10 to 20% yield loss because of compaction. So if you take, say, an average of 200 bushels per acre corn on 1,000 acres, I'll be conservative here with $4 corn right now. Your annual revenue typically would be $800,000. If you take 10% off of that, it's costing you $80,000 for compaction each year. If you go to the higher end, it could be $160,000 on 1,000 acres each year because of compaction. Now we can't get rid of that number completely, but if we can make a 3 to 5 to 8% improvement there, that's going straight to your bottom line. So how do we combat soil compaction? The traditional way to do it is once compaction takes place, we till the soil to try and break up that compaction. But the fact is, tillage never brings it back to its original state. And it breaks down the soil structure to a point where it actually becomes more susceptible to compaction the next time you go across. So hit that again with heavy equipment. Your compaction's worse the second time than it was the first time. Hit it with some more tillage, further degrade the soil structure, compact it some more. You can see where this is going. It's really a cycle you can't win. So how should you go about it? Well, if you stop the compaction in the first place, then you don't have to deal with it, or at least reduce it. These are all factors that impact soil compaction. So we have soil type, which you really can't change to a large extent. Soil structure, soil moisture, traffic timing, traffic frequency, axle load, and weight distribution. A lot of different factors, but the good news is we can control a lot of them. And arguably you can control some aspects of soil type in the fact of higher organic matter makes the soil more resilient against compaction. But if we look at soil structure, reduced tillage and no-till provide additional strength to the soil. So when you're going across it with heavy equipment, it's less likely to be compressed. On the flip side though, you don't have tillage to try and get it out once you have it. Cover crops also provide that. The root mass in the soil also provides additional strength. Water management. If you live in an area where tiling is a thing and you're not tiled, you have to get rid of your excess water because that makes the soil that much more susceptible to compaction. And this is a tough one. When fields are wet, try your best to stay out of it. You know, you have to get the crop planted, you have to get it harvested. But when you're making that conscious decision to go in there when the soil is wet, just know that it's not just a this year impact, it's next year, 5 years, 10 years from now that you could be impacting by doing that. Controlled traffic is a good thing to do if you can. 80% of all compaction in the soil is taking place on the first pass. So if you can reuse those same tracks, you're getting that amount of soil that's being compacted down. Axle load, obviously, if you can minimize your loads and avoid over-ballasting, it's good. It's not uncommon for farmers to try and ballast, have really heavy four-wheel drive tractors, for example, to try and get their slip down. Maybe they want to get it down to 4 or 5%. There's studies out there that show that your peak efficiency with a tire is actually between 8 and 12%. And that's because as you're putting more ballast on your tractor, you're sinking into the soil more, which takes more power just to move that unit across the field. Kind of like Sean was saying before, when you sink in, you're losing efficiency. So if you can avoid over ballasting, have a little bit more slippage, that can help. And then the last thing, weight distribution. Increasing your footprint obviously is going to help reduce compaction. So I talk about that one in depth because that's the biggest issue in terms of the financial impact on your farm. But obviously there's some growers where they're traveling a lot on the road and either they have tracks or they're trying to carry a planter, for example, that's putting a lot of weight on the rear of the tractor. They're trying to run a lower air pressure, so that means, well, instead of going 25 miles an hour down the road, I'm only going to go 15. Well, that's lost time. So, you know, there's a lot of issues that can be addressed. And that's again where the SmartTrac farm plan comes in. So it's a comprehensive guide unique to your farm to figure out how we can optimize any tire or tracks on your farm. And so the process is kind of threefold. So the first thing that we do is we do a fairly in-depth analysis of your operation. So we're going out there and gathering a lot of information. So we're looking at what crops you're producing, row spacing, your current equipment specs, so that would include figuring out what your weight is on each axle and tire for equipment. That's going to play into finding out what your optimal tire pressure is, or if your tires are being overloaded. Your current tire track configurations, what are you using these different pieces of equipment for? Generally, like a tractor may be used on a planter and a grain cart. Well, what can we do if you're not changing tires or configurations between the two? What can we do to bring the best to both worlds as best as we can? And any current issues that you're having on your farm. Like I said, one thing that we can take with this information is figure out, well, what's your optimal tire pressure for field and road for each axle? What's your optimized machine ballasting? Guys that are dealing with power hop, it's a combination of ballasting and tire pressure. And if we can get that in its sweet spot, there really hasn't been a case where we can't get rid of power hop on a four-wheel drive tractor by optimizing these things. Another thing that's part of this are what we call swap smart changeover recommendations. So this is all about what technologies can we use and leverage to make sure that you do have the right tires on your tractor, and not just your tractor, your implements too as well. So This is an interesting case study. So let's just take a look at road pressure for a self-propelled sprayer. So originally with this particular setup, road pressure was 58 psi on the front, 75 psi on the back. If you don't have an inflation system, that's what you're going to have to be running in your field. If we do a swap smart changeover, we can go down to 23 psi and 12 psi for the road travel. So when you talk about going from 75 psi down to 12 psi and the footprint and compaction reduction that you have from doing that, it's a no-brainer. And then the last thing that's a part of this report is a performance report. And this is something that we generate based on your input. We're obviously not the one that's driving your tractor or combine, so we don't know if you're having handling issues or power hop issues. But you let us know what you're having. We'll figure out what we can do to improve on those, and then we can give back kind of an estimate of, you know, this is what we foresee this piece of equipment being able to accomplish with these changes. Since this is a new program that we're launching, we don't have data specific to this program, but we do have data from trials that we've done with farmers implementing certain pieces of this, and then also other independent and university trials focused around, say, reducing compaction. If you can figure out how to reduce compaction, it's easy to see a 3 to 8% yield increase. Or we've tested fuel savings and seen anywhere from 10 to 40% fuel savings by optimizing your equipment. And then, not to mention, helping with all of those other issues too. I mean, we had a farmer just last year swapped out all of his tires on his planters and tractors. The biggest driver, well, compaction's the driver, but actually the biggest driver for him was the road travel and the ride quality. To him, that was such a high value that he wanted to do it for that reason. So again, depending on your operation, your biggest issues and the best solutions will vary. So that is the SmartTrac Farm Plan program. So again, we appreciate you coming out here this morning, and hopefully you were able to gather some useful take-home information. If you missed getting a bag, be sure to get one, a hat, a shirt. They're yours for the taking. And then, as we said earlier, after lunch, Sean will be doing a live demonstration of the tire inflation system. And then while you're finishing up lunch here, we'll also be doing some remaining prize giveaways. So take this time, enjoy a lunch, talk with vendors, and enjoy the rest of the day.